All right, so if we keep working with the normal curve, but now we're considering a case where we've taken a sample of some size, so not an observation, a single observation, but some larger sample. So in this case, n equals 50, our sample size is 50. I'm keeping mu, the population mean, to be 40, and sigma, the population standard deviation, to be 8. And once we take that sample of 50, whatever it might be, maybe we're talking to 50 people or measuring 50 items, we end up with a sample mean, x bar, right? So x bar is from our sample. So sample mean is 38. And basically what a question we could ask is, what's the probability of getting a sample mean that is less than or equal to 38, basically saying, okay, we're below the mean. What are the odds of being this far below or even farther? So we could visualize this. Right? The mean here for the entire population, that would be the same as the mean for our samples of 50, so that's 40. And we're curious, okay, what's the likelihood that we end up there? So, okay, the first thing we have to do is find a z-score. This is slightly different than the z-score we had for a single observation because we don't have x anymore, we've got x bar. So the top looks like x bar minus mu. And then the bottom, we've got to make sure we're incorporating our sample size. The sample size affects our spread, meaning it affects our standard deviation. So we still use sigma, but we divide by the square root of n so that we make sure, right, the larger n is, the smaller the standard deviation gets, the less variability there is. So, okay, let's just plug in our pieces then. So x bar is 38, mu is 40, so it's basically saying how far apart are these two pieces of information, our sample mean and our population mean. Sigma was 8, n is 50, right? And it might help to put parentheses in there just to remind yourself, hey, I need parentheses around that when I put this in my calculator. You can do the same in the numerator there for 38 minus 40. So let's see what that comes out to. So it looks like this is negative 1.77. It certainly should be negative because we are below the mean. So z-scores will be negative if we're below, positive if we're above. And then from there, right, this question of what's the probability, right, what is that shaded area, we can now frame it in terms of a z. So what's the probability that we have a z-score that is less than or equal to negative 1.77? So these two ask the same thing, except here we have raw data, and here we've standardized it. So we can use our table or our calculator. I'm going to use a calculator because I've got that right in front of me. But we're basically looking for this little area, right, what that represents as a percentage. And it looks like 0.0384. That's as a proportion. If you want to write it as a percent, that's 3.84%. So again, you can use your table for this, just figure out what this z-score is, and then double check the visual, right? Are we shading to the left? Are we shading to the right? So sometimes we need, if the table gives us this value and we want this value, sometimes we might have to do like 1 minus this tail. So just be careful. I think the visuals will help a lot though.